Hello everyone, welcome back to our session on orthographic projection in engineering graphics. In the previous session, we saw how orthographic projection is made in different quadrants. In this session, we shall start a new topic, that is projection of lines. In the first part, we shall go through lines parallel to both planes, perpendicular to one plane, and lines inclined to one plane. Then in the second part, we shall move on to the most important topics in lines, that is lines inclined to both planes. So let's move on to the animation and we'll see everything there. Okay, right. So I told you that we'll be discussing about lines parallel to both the planes, perpendicular to one plane and parallel to the other plane. Then the last case, lines inclined to one plane and parallel to the other plane. So first of all, we'll be looking at the most simple case, which is lines parallel to both the planes. Okay, so we have the quadrant system here. I'm looking at the first quadrant, and the pink plane, as we all know, it is the perpendicular or the vertical plane. So not the perpendicular, vertical plane, and we can't see the horizontal plane because you're looking from the front, you're looking at the horizontal plane from the front. So this line represents the horizontal plane in the front view. Now I have placed a line in the first quadrant, and I have kept it in such a way that it is parallel to both HP and VP. As you can see, this line is parallel to this XY line. Now the XY line actually represented the horizontal plane, which means that right now this line is parallel to the horizontal plane. So this is when you look from the front. Now let us see what happens when you look from the top. See that? Now I'm looking from the top. I see the horizontal plane. This is the horizontal plane that we see right now. We don't see the vertical plane. The vertical plane is this line. Okay, this is the vertical plane. Now if you look at this, the line that we have placed here, it is parallel to this line, right? It is parallel to the projection of the vertical plane. So this line is already parallel to the horizontal plane. Now you can see that this is parallel to the vertical plane too, which means that this line is right now parallel to both the planes. Now let us see how do we draw the orthographic projection of this line. For that, we will first switch on the lights, form the shadows, and then we'll draw it. Now let us just look at the side view also. See that this is a side view in fact, and you don't see any planes here because the plane is like that, just very small line here, and you can see a small dot here, right? Now this dot represents the, what can you say, the line. Now we have the vertical plane and the horizontal plane like that, so it is parallel to both. That is the reason why you don't see any line or anything in the side view. Now we'll go to the three-dimensional view. Now in the three-dimensional view, I'll now switch on the light. Okay, I've switched on the light. You can see that a shadow is formed on the vertical plane when the front light is switched on, and when the top light is switched on, a shadow is formed on the horizontal plane. Okay, now as we have done for points and basic introduction to projection of projection of, or basic introduction to orthographic projections, we have marked the front view and the top view. Okay, so we are going to do the same thing here. So I'll just mark the front view, top view, everything. Okay, so I've marked A prime, B prime as the front view, A, B as the top view. Okay, the naming is like that. A prime, B prime is the front view, A, B is the top view. Now this pink line represents the distance of B from the vertical plane, and this orange line represents the distance of A from the vertical plane. Now this line is AB, okay, distance of A from the vertical plane. As you know, since it is parallel, since the line, this blue line is parallel to vertical plane, this orange line and the pink line should be equal in length. Okay, these are called as the end projectors. These two lines are called as the end projectors. So sometimes when you have problems, questions, in that questions it must be given like distance between the end projectors is so much Okay, so distance between the end projectors means distance between this line and this line. We'll see that when I move on to the front view. I'll explain it clearly. Now this green line is the distance of the point B from the horizontal plane, and this blue line, light blue line, is the distance on point A from the horizontal plane. So I'll mark those distance, these shadows. Now if I switch off this light, these shadows will go away. So in order to avoid that, we'll just mark those lines also. Yeah, we have marked those lines. Now since I have already marked everything, even if I switch off the lights, nothing is going to happen. So we'll just remove the line and these projection lines, okay, the distances, and see. Yeah, yes, I've removed the line, I've removed the lines showing the distances also. Now you can see that I've marked the front view as A prime B prime and top view as AB. Okay, the front view is marked as A prime B prime and top view is marked as AB. Now distance from the horizontal plane is marked in green line, and this is almost a brown line, and these two distances are the distance from the vertical plane. As you know, this is the distance from the vertical plane. Now I'm just going to open this. Okay, now we'll see the front view. We'll just make it parallel. Yeah, now if you look at this, you can see that you have this front view A prime B prime and AB. These are of same length, right? These are of same length. Now these are of same length because both these lines, the actual line was parallel to both the planes, and when a line is parallel to one plane, say for example if a line is parallel to the vertical plane, the front view will show the actual length of the line. Okay, that is, if a line is parallel to the vertical plane, then the front view will show the actual length. This is the actual length. Now if a line is parallel to the horizontal plane, then the top view will show the actual length. So this is also the actual length, since this line is actually parallel to both planes. Okay, so now these two lines, that is A prime A and B prime B, are called as the end projectors. Now if in the question it is given that the distance between the end projectors is say some x mm, in that case you have to measure the distance between these two lines, these two parallel lines. A prime A and B prime B are parallel to each other, right? The distance between these two lines along the xy line is the given distance between the end projectors. Okay, now that is all about the lines parallel to both planes. Now we will see the next case, that is lines perpendicular to one plane and parallel to the other plane. Okay, for that I'll first remove all this. Now I'll bring that line. Yeah, now see, I've brought a line which is perpendicular to the horizontal plane. I'm looking from the front. As you can see, you can't see the horizontal plane here, but just the line there. We'll see the vertical plane. We can see the vertical plane. Now this line is actually perpendicular to the horizontal plane. Okay, this is perpendicular to the horizontal plane and it is parallel to the vertical plane. We'll see that when you look from the front, when you look from the top, you can see that it is parallel. Now we'll see the top view right now. See that in the top view you just see a dot here, right? That is because this line was actually parallel to the vertical plane and it is perpendicular to the horizontal plane. Since it say if a line is perpendicular to the horizontal plane, when you look from the top, you don't see the bottom point, right? You see only the top point. You just see it as a single point since it is perpendicular to the vertical plane and it is parallel to the horizontal, perpendicular to the horizontal plane and parallel to the vertical plane. Okay, now let us see the three-dimensional view and then how do we draw this. Yeah, this is the three-dimensional view. Keep in mind that this is parallel to VP, which means in the front view you see the actual length, you see the true length. Okay, the actual length is called as a true length in engineering graphics. In the front view you see the true length and in the top view you just see a dot here. Okay, so I'm just going to switch on the lights, make the markings. Yeah, I've switched on the light, I've marked the distance from the vertical plane and this is the distance from the horizontal plane. This is the front view and top view is just a point. That is the reason why I did not mark anything there. Now since I have marked it, I'll now switch off the lights and remove the actual line. Okay, so when I switch off the lights, I've removed the actual line. Yeah, now see that here we have a line which is perpendicular to the xy line. This is called as the xy line, right? This is perpendicular to the xy line, and the top point is a prime and the bottom point is b prime, because the line AB is perpendicular to HP and the top portion was A and bottom portion was B. Now when you look at the top view, actually this is the distance from the vertical plane. You just have a dot here, okay, because this was perpendicular to the horizontal plane, so it is just a dot here. And see the naming. The naming is given A and B in brackets, B in parenthesis. Why is this B given in parenthesis? It's given like that because you don't see the point B. When you look from the top, when you look from here, do you see the point B? B is just below A, right? So that is why you see only point A. So that is why you give it as A and in parenthesis B. Okay, so this is the orthographic drawing of a line which is perpendicular to one plane. That is, right now it is perpendicular to the horizontal plane and parallel to the vertical plane. Okay, now let us move on to the next topic. Now this is actually very important. The next topic is very important because that gives us a basic idea about how this orthographic drawing is made for lines inclined to both planes. Okay, so as far as university exam questions and everything is concerned, mostly you will get questions from lines inclined to both planes, and sometimes you get application problems also, which we will discuss in the coming sessions. Right now, so for to solve lines inclined to both planes, the best way is to understand the basics of lines inclined to one plane. Okay, so we'll remove this and bring a line inclined to one plane. Okay, I've used the three-dimensional view here because it's easier to understand. Okay, so I've just brought a line here which is inclined to one plane, and this line is right now inclined to the horizontal plane. When you look at the front view and top view, you will see that we'll see the front view and top view. It is inclined to the horizontal plane and parallel to the vertical plane. Okay, it's inclined to the horizontal plane and parallel to the vertical plane. I'll show you the front view right now. See that it is the front view. Okay, now one thing that we have to keep in our mind is this line is parallel to the vertical plane, which means that in the front view you see the true length. Since it is parallel to the vertical plane, you see the true length in the front view, and now it is inclined to the horizontal plane, which means that you're looking from here and you're looking from here, so you see only this much distance, right? You don't see the complete distance, so you see only this much, which means that you will see a smaller line in the top view since it is inclined to the horizontal plane. We'll see that right now. See the top view. This line is actually the top view, and the top view, in the top view you can see that this line is parallel to the vertical plane. So the line is actually parallel to the vertical plane and inclined to the horizontal plane. Now let us move on to the three-dimensional view, and then let us make the orthographic drawing. Okay, now I'll switch on the lights, make the markings, draw the front view, draw the top view, and mark A prime, B prime, etc., and then we will see the orthographic drawing. Okay, so that I have switched on. Yeah, here I have drawn the front view, I've drawn the top view. Okay, you'll understand that this is longer than this line when we when we finish this drawing. Okay, so I'm just going to mark all the other distances. Now this is the distance from the VP, and this orange line is also distance from the VP, and as you know that this pink line and orange line will be of the same length since both are actually parallel to, since the line is actually parallel to the vertical plane. And this line and this line, these two represents the distance of the line from the horizontal plane. These two are different lines because it is inclined. Okay, now I'll switch off the lights and remove the lines from there. Yeah, now you can see the orthographic drawing. Yeah, now look at this orthographic drawing. This is the front view, which is marked as A prime, B prime, and this is the top view, which is marked as AB. Okay, now if you look at this, you can see that this A prime, B prime is longer than AB. What was the reason? The reason was that the line is parallel to the vertical plane and inclined to the horizontal plane. As you can see the inclination here, right? This is an inclination. The line is inclined to the vertical plane. Now the line is parallel to the horizontal plane. Sorry, told the other way around. Okay, line is inclined to the horizontal plane and parallel to the vertical plane. And since it is parallel to the vertical plane, the front view will give you the true length. So this is the actual length and this is a shorter length, right? Now we will move on to the last one, that is a line inclined to the vertical plane and parallel to the horizontal plane. Okay, now I have placed a line there. If you look at the front view, you can see that this line is parallel to the XY line, which means that it is parallel to the horizontal plane. Now if you look at the top view, you can see that it is inclined, so it is inclined to the vertical plane. Okay, it is inclined to XY line. So I'll bring that 3D view again, switch on the lights, make the markings. Right, now I've switched on the lights, I've got the shadows, all the shadows. I've just made the markings there, that this is the front view, this is the top view. Okay, these two, this is the distance from the vertical plane, the pink line and the orange line. In the previous portion we saw that when it was inclined to HP and parallel to VP, this pink line and the orange line were of same length because that was parallel to VP. Right now it is parallel to HP, which means that this green line and the blue line is right now parallel to or of equal length. Okay, now we will just switch off the lights, yeah, and make the final drawing. Yeah, if you look at this drawing, you can see that A prime B prime is shorter than AB, and AB, since this line is actually parallel to the horizontal plane, AB will be of the actual length. Okay, AB will be of the true length. Okay, you have to keep this in your mind because in the next session we will be discussing about lines inclined to both planes, and this point is very important. You get the true length in a particular view, that is in this particular view, that is in the top view. You get the true length in the top view only when the front view is parallel to the XY line. The front view is parallel to the XY line. When it is parallel to the XY line, you get the true length in the other view, that is in the top view here. So if this was inclined, if A prime B prime was inclined, you will never get a true length in the top view. You will get the true length in the top view only when this particular line is parallel to in the front view. So we have to apply this theory in the lines inclined to both planes. Okay, there is some rotation and some things of that sort. I'll explain that in the next session. Okay, right now we will move on and see an actual drawing of this, a two-dimensional orthographic drawing, and then we will wind up this session. Okay, so we will move on to that. Here we have the orthographic projection of a line which is parallel to both planes. We have the line AB parallel to both HP and VP. The XY line actually represents the front view of HP and top view of VP. Now the line is at a distance of 40 mm from HP, above HP in fact, and 50 mm in front of VP. As you can see, point A and point B both are at 40 mm away from XY line, right, above XY line. It means that it is parallel to HP. Similarly, A and B are both 50 mm in front of VP, means it is parallel to VP. And you can see that this line, the length of the line is 100 mm in the front view and 100 mm in the top view. Now since both are parallel to since the line is actually parallel to HP and VP, in the front view and in the top view you see the actual length. Okay, so these two are the true lengths. Now let us move on to the next condition, that is line perpendicular to one plane. Okay, here we have a line which is perpendicular to HP and parallel to VP. When you look from the front, you see a straight line. Okay, now the true length of the line I have chosen, that is 50 mm. In the previous one it was 100 mm. Here I have chosen 50 mm. So I just wanted to generalize things, not to be specific like 100 mm, 50 mm, etc. So I took 50 mm here, not fixing any length. So here in the top view you can just see one point, that is A. You cannot see B because B is directly below A. When it is directly below A, you can say that this line is actually parallel to the vertical plane, because on the top you see only one point. Okay, so when the line is parallel to the vertical plane, what do you see in the front view? You see the true length in the front view. So you see the actual length, that is 50 mm in the front view. In the top view you see only A, point A. That is why I've given point B in brackets. Okay, now we will move on to the next one, that is line inclined to one plane. Right. Okay, here we have a line that is inclined to the horizontal plane and parallel to the vertical plane. You can see in the top view the line is this XY line is actually the vertical plane. So you see a line parallel, when a line is parallel to the XY line means that it is parallel to the vertical plane. And in the front view it is inclined to the horizontal plane. It is inclined to the XY line, which means that it is inclined to the horizontal plane also. Okay, so it is inclined to the horizontal plane and parallel to the vertical plane. Now when it is parallel to the vertical plane, in the front view we see the true length. Here I have chosen the true length as 40 mm. Okay, in the front view I can see the true length. So 40 mm is the true length. Now note that it is not parallel to the horizontal plane. Now when it is not parallel to the horizontal plane, the view perpendicular to the horizontal plane, that is the top view. In the top view you don't see the actual length, you see a reduced length, that is here it is 34.5. This angle is approximately 30 degree. Okay, so this is 34.5. All the other things you can see that this 30 mm, A and B are at a distance of 30 mm from XY line. A prime is at a distance of 30 mm from XY line, but B prime is at a distance of 50 mm from XY line. So one thing you have to keep in your mind is that this you see the true length of the line only when it is parallel to one plane. You see the true length of the line in the front view when it is parallel to VP, and in the top view when it is parallel to HP. Okay, so in the next session we will see the lines inclined to both planes. How do you draw the orthographic projection of that? Okay, so until we see next time, goodbye.